Right, hello, welcome. This is question 2 for M1 November 2002. So this is a scenario in question 2 that we can said particle. So the particle is meant to be on this horizontal flat line. It's obviously very horizontal, but it's just because of my bad art skills. It's a good job I didn't take art. You have floating particles. I mean, in physics we might invent floating particles at some stage, but for the moment I'm just going to assume that it's level, and you can sort of imagine I'm a little bit better at drawing than I actually am. So anyway, we're given this scenario. So as I said, I've drawn this. So the thing I like to do is write down all the bits of information you get given in the question, because you do that in physics and I just become accustomed to doing it. So we've got a particle that is a mass of 1.5 kilograms. There's a force of 3I minus 7.5 newtons. I've sort of written it in coordinate form because that's how it is in the question, but you're more than welcome to write it in column vector form, but I just feel it's because it's given that way in the question. I wouldn't challenge a question just yet. And we've got velocity 2I plus 3j meters per second. So it's all really good. That's the information we've got. The first question says find out the acceleration of this particle. Now what we've got here is we've got velocity, force and mass. Now some of you may be looking at that going, velocity, yes, acceleration, change in velocity over time. Very good, but we haven't got a change in velocity. We've only got a final velocity. We could say the initial velocity is 0, but we're not told that, so we've got to assume that. We've got no time, so it's going to be a bit difficult. So the only other two I've got, so that's the only one that links velocity to acceleration. There's no other formula that does that, apart from v squared equals u squared plus 2as, but that we don't have distance or anything, so that's completely irrelevant. We've got force and mass here. So what links force and mass and acceleration? Because obviously one of these methods is going to work. They wouldn't just give you a lot of information and say, work out the square root of some string theory equation, or work out the supersolid, some supersolids, create a new supersolid. They wouldn't say something like that. So in physics they might, but anyway, get track, back to the maths. So we've got force and mass. The only one that links force and mass and acceleration together is F equals ma. Now remember that's the resultant force, but for this I'm not really interested. So what we've got is force equals mass times acceleration. We've got force and we've got mass, but we need acceleration. So we just rearrange it without putting, I'd not put any numbers in yet, I just rearrange it. So A equals F over M. So therefore A, we just plug our numbers in, so we know the force is 3I minus 7.5 J. I said joules then, Parsons, over 1.5 kilograms. Now, don't get worried about, we're dividing a whole thing by just one integer. We're not really interested in faffing about like that. You should divide individual terms. So therefore A is equal to 2I take 5j. Don't forget the little ones underneath, that's crucial. Now we could stop there and go, well we've got acceleration, there you are, I'm just going to leave it because I'm lazy. Even though I'm lazy, I'm not going to stop there, because I'm not stupid. So, that's acceleration vector, but it wants the acceleration. Now if we said acceleration vector, yes we could leave it there, but it doesn't. It says acceleration. Now the only one that gets us the magnitude of something is by using Pythagoras theorem. So what we're going to do is work out the acceleration of this object. Because we're given it in vector form, that's very good, that is the acceleration, but it's not the one we want. So 2 squared plus 5 squared, now the negative, forget the negative because otherwise you end up with a negative square root, unless you're doing FP1 for pure 1, that's not going to make any sense to you. But it's a really simple method, I have to say. So it's 2 squared plus 5 squared, so it's 4 plus 25, root 29, can't do anything with that, so we'll leave it as root 29. So there's one key thing actually I would stress about just any question in maths generally. If you end up with a surd, it's not necessarily incorrect, though many people think it would be, it's not. You'd always leave it as a surd unless it's set obviously to 4 decimal places, because it's quite hard to do that in the surd form. You've got to go 29.0000 or whatever. You've got to keep it how it asks. Okay, generally leave it in a safe form, that'll be fine. As I said, only 1 mark, so don't worry about too much about that. Alright, so that's part A done. Sorry, part A there. Yes. Part B, it says, so what you can either do at this stage is rewrite all the bits of information out on the next line so you know where you're working from. So I'll do that. But obviously you don't need to. So the mass we know is 1.5 kilograms because part B is obviously going to be using this idea of the acceleration somehow. Force we know is equal to 3I minus 7.5J newtons, and the velocity as a vector 2I plus 3J meters per second. And we've just worked out the acceleration. Now we're going to keep focused on this acceleration vector because we might have to use that. Might, definitely will. 2I minus 5J. And we're told it's accelerating at a rate of root 29 meters per second squared. You don't really need to know that, but I just write that down as well. Okay, so you can sort of, now we've got all the information from this question, we can get rid of it, you know, like an unwanted thing. I was going to say child then, that's quite bad. So that's just got all the information there, that's all we need to know. So we can just work from this, we can just ignore the colours on the board there. Alright, so we don't have to use, what I originally thought of this question, which you might think, is you go, oh, okay, so what equation's got velocity, time, oh yeah, sorry. So find velocity in terms of Ij when p has been moving for 4 seconds. Sorry, t is equal to 4 seconds. So what equation would we have that links velocity, time, the initial velocity, because that's sort of what we've got in terms of the velocity vector, to find the end velocity, the velocity vector? Well, you could say, okay, well we've got that velocity, whereas the r is equal to RO plus Vt, ring a bell? Not going to work for this question because we don't really know the initial velocity. Yes, we've got a velocity vector, but we don't know the initial bit of it. So we can't use that. So it's a lot more simple than you think. This is one of them questions in maths where you have to think about it. It sort of separates the men from the boys or women from the girls, whatever species you might be. I prefer aliens, to be honest. I think they're quite good. Prefer them to humans anyway. So anyway, what we've got here is we're asking what is a velocity in terms of I and j. So in some kind of vector. We can't just say, well, v equals 2I plus 3j and times it by 4. That's not what you do. Because what it wants, we've not got to work. So you've got to think, okay, well we've worked out this, and the question doesn't end there. There's a separate part to it. So you've got to be thinking, okay, well, if I don't see it straight away from the information that was originally in the question, then we have to use this somehow. This idea of acceleration, preferably, the acceleration vector. Okay, so what does acceleration actually mean? So what have we actually worked out in terms of, in terms of a vector? What is this actually telling us? So it's actually quite interesting. Actually, did that on purpose, obviously. So anyway, the acceleration vector is saying, okay, well, it's sort of a rate of increase of velocity. So, because essentially what it is, change of velocity over time. So it's a rate of change of velocity over time. It's the same thing. So far, it's basically saying every second a velocity increases by that amount. And as we're travelling 4 seconds, then this is going to be increasing 4 times. So therefore, but we were already travelling at a velocity of 2I plus 3j, but each second we add on, we're increasing our velocity by 2I to minus 5j. So therefore the overall velocity, which is going to look a bit weird, is 2I plus 3j plus 4 times 2I take 5j, which is the velocity vector, the acceleration vector we worked out before. Okay, so expand this out, so therefore I'm going to put VF here. It's not really good, especially if you're doing medical stuff. So VF is equal to, I'm going to write that again, so 2I plus 3j. Expand that out, so that's plus 8I take 20j. So if we simplify this down, so therefore VF is equal to, take up the j's and the i's together. So it's 10i take 17j. Okay, so if we were to rewrite this out as a proper formula, so we could sort of create this formula, but we did use the idea of r equals r0 plus vt, but we sort of changed it around to use a similar idea, but didn't quite use the same. So anyway, we can see what it means when I write out. This is essentially the equation I used. So this is Vf is the final velocity, V0 is the initial velocity, plus t times acceleration. I'll just put a, and then you could put in there delta v, same thing. So that's essentially the equation that we've come up with, and we've used this equation. All we did to think about this equation, to come up with it, is think, well, what does acceleration actually mean? As we know, it's a rate of change of velocity. It's rate of change of velocity, so it's going to be change of velocity to do with time. So therefore, we just created this equation. It's quite similar to saying r equals r0 plus vt. Do you see how they are quite similar? So we did use the idea of that, but we didn't use it specifically to the letter. So we sort of came up with our own individual signs for this. But essentially, the equation remains quite similar. But I didn't want to get you thinking about this equation because you go, oh, well, we suddenly need to change R0 from what all we've been teaching throughout the whole year. Or what, how long you've spent watching this? No idea. Totally up to you how much of your life you want to waste listening to me. You know, that's up to you. I have to listen to myself all the time, so think how bad it is for me. You can shut me down. I have to continue with it, live with it. So anyway, that's question 2. Nice and simple question. It's worth 7 marks now. So you know, we're good. 13 marks of the paper there. So it's, you know, it's a good chunk of the paper. It's been fairly easy. This question is again. With the first question, it's just about thinking about what you've got. So the first 2 questions haven't been necessarily difficult in terms of the maths behind it, because anyone could really do that. Like even if you didn't, if you just did first year physics, you could do and you understood about vectors. You could work that one out even without learning the mechanics syllabus really too much. So as I said, that's quite a really simple idea. So thanks for watching question 2. We'll see you in question 3 and see if you survive that one as well.